Now we will move through the next cipher, the permutation cipher. Permutation cipher. The next cryptosystem. Cryptosystem 1.6. Permutation cipher. Here, m is a positive integer. M belongs to z plus, and let p equal to plain text is equal to cipher text is equal to the m copies of z26 is z26, m copies of z26, and let k, the key, script k consists of all permutations of 1, 2 up to m, where m is a positive integer. For a key that is a permutation pi, we define e pi of x1, x2, etc. xm is equal to x pi 1, x pi 2, etc. x pi m. This is our encryption function e pi, and d pi is defined as d pi of y1, y2, etc. ym is defined as y pi inverse of 1, y pi inverse of 2, comma, etc. y pi inverse of m. Therefore, actually, decryption, we will use the inverse permutation. Pi inverse means the inverse permutation of, pi inverse is the inverse permutation of pi, inverse permutation of pi. Therefore, in permutation cipher, we have PZ is m copies of Z26, K is the permutation on 1 to m, where m is a positive integer, and E pi and D pi are defined in this manner. As an example, permutation cipher, example 1.7. Suppose m equal to 6, and the key is the following permutation. Key is the following permutation. Permutation pi, that will permute x, then pi x. It will be like this: 1, 2, 3, 4, 5, 6. Totally we have m equal to 6. Permutation is like this: 1 is going to 3, 2 is going to 5, 3 goes to 1, 4 goes to 6, 5 goes to 4, and 6 goes to 2. This is the permutation pi. Now, permutation pi inverse will be x pi inverse of x. Suppose we will write again 1, 2, 3, 4, 5, 6. What will be the inverse permutation of 1? That is, 1 goes to 3, 2 goes to 6, 3 goes to 1, 4 goes to 5, 5 goes to 2, and 6 goes to 4. This is the inverse permutation. Okay, 1 goes to 3, 3 goes to 1, 2 goes to 5, and 5 goes to 4, and so on. Okay, sorry, 4 goes to 5, and so on. Okay, therefore this is pi and this is pi inverse. Now suppose we are given a plain text like this, that is, plain text consists of she sells seashells by the seashore. A meaningful plain text, she sells seashells by the seashore. We have to encrypt this by using permutation cipher. For that, M consists of 6 elements. Therefore, we will try to divide the whole message into each having 6 elements. She, S, E, L, 2, 4, 6. Then L, S, S, E, A, yes. Next is 6. Next is H, E, L, L, S, B. Then Y, T, H, E, S, E. Finally, we have A, S, H, O, R, E. Ashore. Therefore, first of all, we will divide this whole message into messages with 6 elements. അതായത് നമുക്കൊരു സംശയം തോന്നാം അവസാനത്തിൽ എപ്പോഴും 6 ഉണ്ടാവണോ ഇല്ലേ എന്നുള്ളത്. സാധാരണ ഒരു പാഡിങ് നടത്താറുണ്ട് അവിടെ നമ്മൾ എല്ലാത്തിനും എലമെൻറ്റ്സ് ഇല്ലാത്തവനൊക്കെ 0, 0, 0 കൊടുക്കുന്ന ഒരു പാഡിങ് സിസ്റ്റം കൂടി ഇൻട്രൊഡ്യൂസ് ചെയ്യാം വേണമെങ്കിൽ. അതങ്ങനെയാണ് ചെയ്യാറ് സാധാരണ ചെയ്യുമ്പോൾ. ഓക്കെ, അപ്പോൾ ഇവിടെ പക്ഷേ എളുപ്പമുണ്ട്. നമുക്ക് 1, 2, 3, 4, 5 30 ലെറ്റേഴ്സ് ഉണ്ട്. അതിനെ നമ്മൾ 6 ആക്കി വെക്കുമ്പോൾ 5 എണ്ണത്തിൻ്റെ ഗ്രൂപ്പ് നമുക്ക് കിട്ടും. Okay, now here we arrange the letters according to pi. Then the decryption is ഈ പൈ അനുസരിച്ചിട്ടാണ് ഇനി പിന്നെ ലെറ്റേഴ്സ് ക്രമീകരിക്കുക. ഇതിന് ഓരോന്നിനും ഓരോ യൂണിറ്റ് ആയിട്ടാണ് പരിഗണിക്കേണ്ടത്. 6 എലമെൻസിൻ്റെ യൂണിറ്റ് ആയിട്ടാണ് പരിഗണിക്കേണ്ടത്. ഇവിടെ 6 എലമെൻ്റ് ഉണ്ടെങ്കിൽ നമ്മൾ ചെയ്യുന്ന പണി എന്താ വെച്ചാൽ ഫസ്റ്റിന് 3ലേക്ക് വിടണേ, സെക്കൻഡിനെ 5ലേക്ക് വിടണേ, തേർഡിനെ 1ലേക്ക് വിടണേ, 4നെ 6ലേക്ക് വിടണേ, 5നെ 4ലേക്ക് വിടണേ, 6നെ 2ലേക്കാണ് വിടുന്നത്. അപ്പോൾ ആ ഓർഡറിൽ നമുക്ക് ഡിക്രിപ്റ്റ് ചെയ്യുമ്പോൾ ഡിക്രിപ്ഷൻ ബിക്കംസ് യെസ് ഫസ്റ്റ് മസ്റ്റ് ഗോസ് ടു തേർഡ് വൺ, ഫസ്റ്റ് വൺ ഗോസ് ടു ഇ, ദറ്റ് ഈസ് ഇ, then second goes to 5th one, again E, third one goes to first one, that is yes, fourth one goes to 6, that is L, fifth one goes to 4, that is yes, and the 6th one goes to 2, that is H. Therefore, the first group SHESEL is decrypted as WSLSH. We can do the same for the second group as well. First element is mapping to third element, that is yes. Second element goes to 5th element, that is A. Third element goes to first element, that is L. Fourth element goes to 6th element, that is yes. Fifth element goes to 4th element, that is E. and the sixth element goes to the second element, that is yes. Therefore, our 1SSEAS is decrypted as SALSES. In a similar fashion, the next group can be decrypted as, first goes to 3, that is L, second goes to 5, that is yes, third goes to first one, that is H, fourth goes to sixth one, that is B, fifth goes to fourth one, that is L, and the sixth goes to the second one, that is sixth goes to second one, that is E. Therefore, the middle portion, that is HELLSB, is encrypted as LSHB LE. Then find second, last but one, that is first go to 3, that is 3 means H, 5, that is yes, 1, that is BY, Y, 6, that is E, then 4, for this E again, 2, that is T. Thus we have YTHESE is decrypted as HSYWT. Then finally, the last lap, third one H, fifth one R, first one A, sixth one E, fourth one O, and finally second one, that is ES. That is Ashore is decrypted as HRA EOS. This is the decryption by using this permutation encryption, that is pi and encryption formula. Now this can be decrypted by using the inverse one. In inverse, we'll go 1 goes to 3, that is third order. We'll take the third one yes, then sixth H, SH, then we'll take first one, that is E, fifth one yes, then second one, that is E, fourth one EL, SEL, SEL. The same manner for inverse, pi inverse, we have third one, that is L, small l, sixth one, that is S, first one S, fifth one, that is E, next one, second one S, and so on. Therefore, decrypted one can be decrypted like this, encrypted one can be decrypted like this. We have 5 groups, each group consists of 6 letters. ഒരുമിച്ച് എഴുതുക. അപ്പോൾ എന്ത് കിട്ടും? She sells seashells by the seashore. This is the example pertaining permutation cipher. And we can conclude that, as a note, we can conclude that the permutation cipher is a special case of Hill cipher. In permutation cipher, we have the permutation. Given a permutation pi on the set 1 to m, we can define an associated matrix, m by n matrix called the permutation matrix. Hence, the permutation matrix K pi will be obtained from this permutation matrix. Permutation matrix. Actually, this permutation matrix consists of the identity matrix of any order can be permuted row-wise, column-wise, etc. That is known as the permutation matrix. Here, the permutation matrix will be obtained like this. Permutation matrix will be obtained in the following manner. K pi is the permutation matrix with the permutation pi. It is having elements Kij, the matrix Kij, where Kij is nothing but Kij is equal to, element Kij is equal to 1 if I equal to pi of j and 0 otherwise. I will define permutation matrix K pi. K pi is defined as matrix Kij, where the element Kij, that is Kij means ith row le jth element, is 1 if I equal to pi j, 0 otherwise. A permutation matrix, നമുക്ക് ഇതിൻ്റെ തന്നെ ഒരു പെർമ്യൂട്ടേഷൻ മാട്രിക്സ് ഇത് ഉപയോഗിച്ചിട്ട് കണ്ടുപിടിക്കുക. ഈ പൈ പെർമ്യൂട്ടേഷൻ വെച്ചിട്ട് ചെയ്യുകയാണെങ്കിൽ, as we know, x and pi x is like this 1, 2, 3, 4 up to 6. It is permuted as 3, 5, 1, 6, 4, 2. Now we will start with this permutation matrix K pi is defined as Kij. How it will be forming? Every element in K pi will be of the form Kij, that is ith row jth column element ആണ് Kij, is equal to 1 if I equal to pi j and 0 otherwise. Therefore, what will be the value of K11? K11 equal to 1 if I equal to pi 1, but pi 1 equal to, pi of 1 equal to 3, not equal to 1 ആണ്. That must be equal to 1. Therefore, the value will be equal to K11 value is equal to K11 equal to 0. What about K12? K12 in the value കിട്ടണമെങ്കിൽ, this according to this definition 1 ആവണമെങ്കിൽ, that is ഇവിടെ I is 1 here, 1 must be equal to pi of 2. Pi of 2 is 5. Therefore, these are not equal. Therefore, K12 is also 0. The next one, K13. K13 equal to, here is a peculiarity. What is I here 1, j is 3. Therefore, 1 should be equal to pi of 3. Is it correct? Yes, 3 goes to 1, which is equal to 1. Therefore, K13 is 1. The remaining terms are all zeros. That is K14 equal to K15 equal to K16 is equal to 0. The next is K21. K21. You can check that. This is very easy to calculate this permutation. That is, here it is 0, 1, 0, 0, 1, then 0, 0 elsewhere. The next one is, as you know, 2, 2. It is happening when pi of 6 is equal to 2. Therefore, the sixth element will be equal to 1. Therefore, the matrix can be constructed like this. This k pi can be constructed like this. 0, 0, 1, 0, 0, 0. Then 2 goes to 2 coming here only, 6th position. Here 1 coming in the 3rd position, we have 3rd position 1. Here 2 is coming in the 6th position, therefore elsewhere zeros, after 5 zeros we have 1. Next one is 3rd one, that is 2, that is 3, therefore 3 is coming here, 3 is this 3 coming here, therefore first position we have 1. The next will be 4th one. What will be the position of 4 here? 4 here. Therefore we have 0, 0, 0, 1, 0, 0. No. 0, 1. Next, 5th one is in the 2nd position, therefore 0, 1, 0, 0, 0, 0. And 6th is in the 4th position, we have 0, 0, 0, 1, 0, 0. Thus we got the permutation matrix K pi. It is obtained by using this rule. This rule, Kij is equal to 1 if I equal to pi of j, and otherwise it will be 0. We noted that K11 equal to 0. What is the reason? K11 equal to 1 ആവണമെങ്കിൽ 1 must be equal to pi of 1 ആയിരിക്കണം. pi of 1 പക്ഷേ 3 ആണ്, അതുകൊണ്ട് 0 ആവും. അത് അങ്ങനെയാണ് ആ പ്രൊസീജിയർ കണ്ടിന്യൂ ചെയ്യണേ. ആൻഡ് എളുപ്പവഴിക്ക് സാറ് പറഞ്ഞായിരുന്നു എന്ത് ചെയ്യണം, 1 നോക്കിയ പൊസിഷനിൽ നോക്കിയാൽ മതി, 3rd പൊസിഷനിലാണ്. അപ്പോൾ 1 ഈസ് ഇൻ ദ 3rd പൊസിഷൻ, ദെൻ 2 ഈസ് ഇൻ ദ ലാസ്റ്റ് പൊസിഷൻ, ആൻഡ് 3 ഈസ് ഇൻ ദ ഫസ്റ്റ് പൊസിഷൻ, 4 is in the 5th position, and 5 is in the 2nd position, and 6 is in the 4th position. Therefore, we got K pi. In a similar fashion, we can find K pi inverse, that is K pi inverse. K pi inverse is the same as K pi whole inverse actually, but this is somewhat easy. K pi inverse, we have the inverse permutation is like this, pi inverse like this. Therefore, 1 is in the 3rd position, therefore we have 0, 0, 1, 0, 0, 0. Then 2, that is in the 5th position, 0, 0, 0, 0, 1, 0. Then 3rd, that is in 1st position, 1, 0, 0, 0, 0, 0. Then 4, here in 6th position, 0, 0, 0, 0, 0, 1. And 5 in the 4th position, 0, 1, 0, 0, 0, 4, 1, 0, 0. And 6th is in the 2nd position, 0, 1, 0, 0, 0. This is K pi inverse. That is 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0 elsewhere, 0 elsewhere, last one, 0, 0, 0, 1, 0, 0, and 1, 0, 1, 0, 0, 0, 0. And you can verify that this K pi and K pi inverse, that is the same as K pi whole inverse. Multiply these matrices together, we will get the identity matrix. That is very simple to calculate. Thus, multiplication with the first column will get 0 into 0, that is 0 plus 0 into 0, 0 plus 1 into 1, 1, and 0 elsewhere. The first element is 1. And similarly, the whole other elements are all 0 because position is different. Okay, therefore, we will get K pi into K pi inverse equal to the identity matrix 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0 0 1 0 0 0 0 0 0 1 0 0. The next one 0 0 0 0 1 0 and 0 0 0 0 0 1. They were inverse to one another. Now, as an example, for example, we try to encrypt, for example, 6-element name. You are familiar with this one, Jomesh. Yes, 6-element encryption. Encrypt Jomesh. Because that name consists of 6 elements. 6 elements. Using permutation cipher, as in the case of Hill cipher, convert Jomesh into numbers. It will be 9, 14, 12, 4, 18, and 7. Encrypt using K-pi. Encrypt using K-pi. K-pi is the matrix. Ek of x is equal to xk. That is equal to x, you know, this 9, 14, 12, 4, 18, 7. This matrix K, x into K. K, we have the invertible matrix already we have. Zero, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 1, then 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, and 0, 0, 0, 1, 0. That is the permutation matrix K. That is equal to, on multiplication we will get the first element 0, 0, 12, then 0 elsewhere. The next one is 0, 0, 0, 0, 18, then 0. That is 18. The next element will be first element itself 9. Here the last element 7. And here this position, last but third position 4. And here is second position 14. Therefore, encrypted form of EKX, that is XK, that is equal to 12, 18, 9, 7, 4, 14. This is equal to 12 M position, 18 is S, 9 is J, 7 is H, and 4 is E, and 14 is O. Therefore, Jomesh is encrypted like this, MSJ HEU. This is the plain text, and MSJHEU is the ciphertext. Now, by using this inverse matrix K-pi inverse, we can decrypt dk of x is equal to, or dk of y, this is our y, dk of y is equal to y into k inverse, that is equal to 12, 18, 9, 7, 4, 14, all into this K pi inverse 0 0 1 0 0 0 0 0 0 0 1 0 1 0 0 0 0 0 0 0 0 0 0 0 1 0 0 0 1 0 0 0 1 0 0 0 0. Multiply these matrices together, we will get this row into this column. It is third element. Third element is 9. That is equal to the matrix 9. The next is 14. Next multiplication, we will get the first element, that is 12. Next multiplication will be last but 1, that is 4. Next multiplication is second, that is 18. Third multiplication is last but 1, that is 7. Okay, this is the decrypted form, that is 9, 14, 12, 4, 18, 7. 9, 14, 12, 4, 18, 7. This is nothing but our geometry. Okay, this was the permutation cipher is a special case of Hill cipher.